That does not inspire confidence. Okay, well, you guys are doing really good on the homework, so I have faith in you. Okay, I just put up the link if you wanted to join by Zoom as well as be here, so that's on Moodle. So I actually haven't seen you guys in a little while. Because River gave a guest lecture. How did it go? Yeah. Okay, well, we're going to go over if-else statements a little bit to kind of warm ourselves up. And then we're going to spend some time talking about different data storage structures. Up until this point, we've been working with data frames and tables from tidyverse, but there are a few different other types that you will encounter that you just need to be aware of and what they mean. So we'll do that for a little bit too. Okie dokie smokies. I need to go like this. No. I don't want to see myself either. All right, let's do this. Okay. Can everyone see the screen okay? Yeah. Just saving this for our class notes. Okay. We're going to practice if-else statements. Okay, so we're gonna need some data to play around with. Let's go ahead and go find some. I'm just gonna pull some off the top of my head. We can go ahead and load little fish. Do not set my working directory, so I need to do that. Oh, yeah. Thank you for that reminder. Did I say tiny fish or little fish? I forget. Tiny? All right. We're gonna foster a Chihuahua puppy. Okay, you guys know how my grad students. I have an issue with rescuing dogs, and this is why I'm saying related to Tiny. They're like, does anyone want to foster a 7-week-old Chihuahua puppy? And I was like, I'll do it. I have 3 dogs, but it's fine. But I want to name him Pico. Anyway. I'm sure it's going to be a challenge because puppies pee all the time. Okay. Oh, no, you, thanks. All right, in our environment, I'm not going to talk until then. Okay. You got this. Go ahead and who's having the echo back? Do you need some help? Is that a yes? Okay. That's better. Nope, still the voice of God.
It's from like a previous, like which one?
Did you find it? Good morning. Okay, so when we load this in, the object is called tidyfish and it's a little verbose. So if I want to change the name of an object that's loaded in, how do I do that? How do I reassign? This was a question that some of you had. So let's say I just want to call it this. I heard an equal sign, right? Tiny fish, that's right. So now we have duplicate objects, just with different names, and I can, if I wanted to get rid of tiny fish in the, just do the remove function, it'll take it away from my environment. Okay. Okay, so who can tell me what is the purpose of an if-else statement? What are you trying to, like, let's talk about the structure a little bit. Maybe that's going to help with that, right? So, because it's going to be used in certain circumstances. All right. So it starts with, there are if-else functions in the base R as well as in things like tidyverse. So we'll look at both of them. And I know this is review because River did a great job, but trying to get our brains warmed up. Okay, so this is using the function from base R. And I'm just going to tap my tab key here to bring up the arguments. Okay, so there's three main parts to an if-else statement. A test of a condition, what the outcome is if the answer is yes or true, essentially, and then what to do if the answer is false. Or no. Okay. So let's brainstorm a little bit. Let's say we want to assign a value based on a condition in another column, right? That's one way we could use an if-else statement. So we can practice this. Let's see here. If D, let's see here. So we'll part this argument. There's three parts. The test, which is a condition. Yes. What happens if the condition is true? And no. What happens if the condition is false? Okay. let's say we want to make a new column that's going to have a value of, let's think about this, a value of A if the value, it's going to contain a value of like the letter A if the value of parcel ID is less than 5. And in all other cases, the value that would be given for that column would be B. Okay. Yeah. So what would that look like? We're going to have to assign a new column. So we're going to call this, I don't know, we'll call it X. So the first thing we need to do is tell it what condition we want. We're testing the condition that if the value in our parcel ID is less than 5, then we want to tell it what to do if that condition is met. So in this case, we already are assigning it to this column here. So we don't need to be explicit about where this value goes. That's already kind of integrated here because it's going to go over here. So we're just going to say A. And then the last argument is like what to do if it fails, if the condition is not met. And we want it to assign in other cases B. Okay, let's see if this goes. All right. All right. So I'm looking here at a new column that I just made. And we see that, let's scroll a little bit to make this a bit more illustrative. There we go. Okay. So this is our parcel ID column, right? And so when we get to 5, it's here and here, we see that a value of D has been assigned. But for 1 through 4, a value of A. Okay, so let's think about why this could be useful. Sometimes I do this kind of statement if I'm trying to like quickly get a count for something. So we're going to repeat this, but we're going to use, let's first say we're going to use our parcel length here because I'm going to want to answer the question, well, how many patches or parcels are like, let's say less than 20 meters in length, right? And so to do that, I could, if I wanted to, I could like subset them out, but this is another way to do it. So, okay. How many parcels have a parcel length M that is less than or equal to 20 meters? Okay, so this is really a two-part question, right? So the first thing we need to do is identify the parcels that are less than equal to 20. So we're going to use an if-else statement to answer this question, even though I think probably instinctively you're like, well, why don't we just subset them out? Because that would be faster. Okay. Bless you. I'll call this PL. PL 20. Okay. If else. So our condition here is now we're dealing with our parcel length. And I'm doing less than equal to 20. That's our condition. And so I want to count. So I actually want to, if the condition is met, I want to assign a value of 1 and all other values be 0. So that when I count that column, I just end up with the right like total. Does that make sense? Okay. So if true, assign a value of 1, otherwise assign a value of 0. Write this down. Okay. Okay. So we've made a new column, PL20. And so we can see that if it's less than 20, it's got a value of 1. If it's greater than 20, it's got a value of 0. Okay. So our next part of this to answer the question is we need to summarize. So the quick way really is to just do this. It's really to find the total. So I don't do a fancy function. Find the total of the column PL20. So it's just sum D PL20. There are 157 rows that meet that condition. Okay. Let's load up tidyverse and we'll look at tidyverse's version of this this type of else statement. Okay, so it looks a little different. You'll see that there is an underscore here. All right, let's look at the arguments. It's going to be very. This is the just from dplyr. It works the exact same way. It's just the arguments are named a little bit different. Condition, true, false versus yes and no. I'm just going to repeat this and we'll say less than 40. So in this case, we're going to use that. And so now it's condition and the argument is whether it happens if it's true. And then instead of no, it's what happens if it's false. So we just changed the condition here, but the whole structure is the same. Okay. All right, so let's talk a little bit about a more complex structure for if-else statements. And these are used, I use these often when I'm, what's a good way to think about this? I need to assign a value to an object which is kind of how we use it in the very basic sense that we're doing it now. But I may need, that's what it is. Usually I need to test a series of conditions. So in these basic if-else statements, we note that we can only test one condition. I can show you what happens if we try to test two. It'll fuss at us. It'll say, you're trying to test two conditions, only the first condition will be met, which means I can't test two things at the same time. I can only do one time. So there's a different structure if you want to test things like a series of conditions and then assign a value. All right, what does that look like? Okay, I'm not going to use little fish for this. We're going to take class pull here, getting moderately close. Well, it's technically fall, right? All right, so we're going to, what are your favorite fall things? So I'm just going to make a new object here. Fall. All right, I need like 5 things that you love about fall. What? Oh, yeah. Okay, that's a good one. Birthday. It's your birthday. Last one. Wow. I would have bet $5 if someone would have said pumpkin spice lattes. Slash shaking heads here. All right. What? It's okay. I'll take the heat for you. I don't even like pumpkin spice, but it's definitely like part of now the fall culture. Okay. All right, so this looks like this more complex structure looks like this. If fall oh good lord. Okay, so one of the main differences here is you may notice I'm using these curly braces. I have to separate them up. Okay. Not doing this right. Hang on a second. I'm not going to show this correctly. Okay. I'm going to create it where it's going to throw us an error, and then I'm going to fix the error to see what you're talking about. Okay, so here's our condition, and it's a logical one. So I'm saying look into the object fall and see if it has the value apple cider. So if we just ran this by itself, we can do that. Just, in our environment, this is, we're asking a logic question. It's going to go through all the values in our fall object and test them, right? So that's why we get false, true, 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 false, false, and then the rest. Okay. So in this first part, this is where we return the value if the condition is met. So we'll say, emotion equals happy. Else, wow, I can't spell. Lord help me. Okay, else our emotion is, meh. Okay. So note that I haven't defined emotion already. It's not in our environment. Bless you. So we're defining it here in our if else statement. Okay. So when I run this, it's going to give me an error because I have multiple conditions. Okay, let's dissect this error message, because this comes up a lot when you're building these. It's very common. Okay. All right. Tell me what this means. The condition has a length greater than 1. Where is our condition at in our? This is where the condition's at, right? Say that one more time.
Condition is land is one means apple cider is apple cider more than one time.
No, not quite. So look at line 34. How many values belong to object fall? 5, right? Yeah, so I'm going to scroll up here for a second. When we asked it to evaluate here in our environment just by itself, whether fall was equal to apple cider, which is what we're doing here, right? We're saying check this. And so it's doing this work. It's going through each one of those values and saying, is it apple cider? No. Yes? No, no, no. And so it gets grumpy and doesn't like it. It's not going to work properly because you're asking it to evaluate multiple values here rather than just one. It says that you're evaluating multiple conditions. So it only wants one of these. I think this is one of the key differences. It is one of the key differences between this type of if-else structure and the one that we used previously up here, right? Because the one we used up here, it was totally cool that there was multiple values in that parcel ID. It just went row by row, right? And it tested each one individually. Here, it's like taking the object fall and it's trying to test them all at the same time. So this structure is good if you work in a data frame and you want to evaluate row by row of whether a condition is met. You can't use this new structure that we're kind of looking at to look at multiple conditions simultaneously. Okay, so too many curly braces. So to fix this, I'm just copying this right now to save myself some typing. To fix this, I'm just going to pull out the second value in our fall object, which we know is apple cider. So when I run this, it's apple cider. And so I know when I do this, it's just going to yield one true, right? Because I'm just asking it about one part, one component. Okay. A little messy. Okay. All right. So this will work now. All right, so emotion did pop up, but if we look, it didn't pop up on our console here, but if we look in our environment, we have the new object emotion, and it's happy because the condition was met. Oops, let's copy and paste this. So let's make this condition false. So if I run this, it's going to yield a false. And we should get a different value for emotion. It should become meh. And it overwrites it and becomes meh. All right, so this seems like a rather awkward way to use this. You're probably thinking to yourself, why in the world would I use this? Let me show another example, and then we'll try to use a somewhat more applicable example of how this works. All right, so the next level here is using a second condition, which is why we started doing this, using this one in the first place. Okay. So we're going to go if fall to, and we're going to have this fail equals beer. We need our curly braces. So instead of assigning a new object here in this section where what we do if the condition is met, I am asking it to test a second condition. Yeah. Okay, let's try to get this right. If the condition above about is found to be true, this is key. If the condition above is found to be true, no, this needs to go here. Yeah. Then emotion is equal to yay. Okay. If the condition above is found to be false, then we're going to test a second condition. So our second condition is this. This is the second condition. So we're saying here, okay, is the value in fall 2 equal to beer? We know this to be false, right? So what it's going to do is it's going to skip over this. It says this condition is not true. So I'm skipping over this part, right? Not assigning a motion to yay. And then it's going to go to this next condition test that we've set up here called else. They set it up by using else if. So then we say, okay, so if that was false, test this thing. Is this condition met here? And we know that this is true, right? Then do this thing. And so Lord, the spelling. Call it fuzzy. Okay. So the outcome of this if-else statement should be the emotion fuzzy because this isn't met. And then we know that the second set of conditions is met here. Okay. All right, so we look at our environment and we see that we get the emotion fuzzy. So the key things of this structure is these curly braces. Okay, so the last thing we're going to do with, no. Oh, I just wrapped it up. You've got these little triangles, you can wrap it up. Okay. Sorry, guys. Okay. So we can also say, what happens if none of the conditions are met? Just for grins and giggles here, I'm going to rerun the objects of fall so that we can see them again because it's been a hot minute. Okay. So we're now kind of going through a series of conditions here. So we know on line 79 that that's false. We now know on where you just changed this on line 83, that's been set to false. And so it's going to go, is this true? Nope. Is this true? Nope. Okay, what else? What's the last thing you want me to do? If everything else has failed. So it's what value should be returned by default. Let me get this a little bit more easy to see. That's not what I wanted to do. When these don't, you may notice like this is highlighted here, this little curly brace, right? Our studio tries to help us out because there has to, these curly braces have to show up in pairs. It's like, it's kind of like our C sandwiches, right? We'll have to make sure that our parentheses match and come in pairs. It's the same thing with curly braces. So I have a pair here. And then I have my second pair here. I can highlight it. No, not that part. All right. So this one goes with this one, and this one goes with that one. So often if you are writing these and you get the plus sign, it means that the task that you're trying to do is not finished. It's usually a curly brace issue because you've forgotten one. It'll also tell you. So like if I get rid of this, let's see here. Did I have an extra one? No. Okay. Usually you yell at me. Okay. So that's why I was like, why is it not yelling at me? Because I had an extra one. Okay, so if I delete this one and get rid of the last pair, it gets a little red X and it says unmatched opening bracket. So it says, hey, you're missing one. Okay. So now we put that back to make it even, Stevens. And then we're going to run this. All right, our motion is confused. You guys follow that? Okay. All right. When to use this more complicated if else structure. I use it if a lot of times if I'm trying to make graphs dynamically, and like you probably encountered this, like one set of data will have like a range of like 0 to 10, and then another set of data will be like 20 to 50, right? And so you want to be able to essentially like automatically tell it what the range should be for your graph. So setting max values in a plot based on the range of your data. Another way that I use this, another way that I use this is sometimes when you're subsetting data, you'll get data frames that have 0 rows, right? Because the condition wasn't met when you selected it. So you want to be able to essentially not perform a function on a 0 row data frame because it gets mad at you, right? Because you're trying to do something that has no data. So skipping over data frames that have 0 rows. That looks like this. If the number of rows in is equal to 0. So let's say, I think we just have D in here. Yeah. So I'm asking it, are the number of rows in our data frame D equal to 0? And it should say no. It says false. Okay. Then do stuff. And then you can say, let's say that condition is met. And like, you can't do anything with no data, right? Else. And you can actually just leave these empty. And it means do nothing. A cleaner way to do that, this is the same way. If n row D is equal to 0, this is also a very equal valid way to do this. And I just have that's it. You don't have to, if you're telling it to do nothing, you don't need the else statement. I call these kind of things try catches, because it's trying to do something, and then if you try to run stuff on like no data, it's going to throw an error when you are trying to run your stuff. So like if you're iterating and you're going through like you're subsetting data like with a condition over and over again, and one section doesn't have any data, it'll stop your running, stop the run if you get an error. So this is a try catch where it says, hey, is there data? No, there is not. Okay, move on to the next thing. When you are iteratively going through a data frame, well, no, going through data split by a condition and performing functions. All right. It's really all I want to kind of make sure review about if-else statements. Does anyone have any questions about these before we move on to our different, yeah. No, can you help me out here? Which one do you mean the first one? This one? Let's see here. Oh, it's not supposed to be. Yeah, okay. All right, correction. I appreciate that. This got to go. The reason it returned a null is because null is our special value for empty. And so when we had our empty curly braces after else, it returned nothing, right? And so this is a fix. This is actually tells it to take no action. So please delete that. I'm sorry. All right, any other questions? Yeah. Can you use a different function? Yeah. What other function are you going to use? What? Oh, I don't use that one. Okay. Oh, okay. Is that a dplyr thing? Okay. Yeah, there are a lot of different functions and ways to do this. So like anything. Okay. So we're going to switch gears and talk about different data storage structures. So up until this point, when we look at, let's say we pull up our tiny fish, we've been working with a data frame, right? So if I do class structure D, it's going to tell us that it's a data frame. Data frames are very kind of intuitive for us to work with because they essentially look like an Excel file, right? They've got rows, they've got columns, usually have headings and things like that. So it kind of makes this easy. But data can come in multiple dimensions and be put in some different structures that you may encounter. This is particularly true for scientific data that's collected with like satellites. And so the data may have multiple layers to it because there could be the measurement, the lat and long, the geographic coordinates, a time dimension to it. And so instead of just having a 2-dimension item, which we have a data frame, there may be like 4 dimensions to it, right? The data, the time and the space, and the time to it. So what does that look like? And how do we access it? Okay. All right. So we work with data frames. I'm not going to harp on this. Data frames are 2-dimensional. You can make a data frame if you want. It's DF, and the call for that is data frame. I usually use this when I'm trying to basically collect objects into a data frame to work with. So if I have like objects hanging out by themselves with different values, I want to put them all together in a sheet that I can kind of work with. So let's see here. We're going to use our fall objects here. And so we'll just say, I'm going to go fall 1. So just for grins and giggles, this is what we're working on. So fall 1 is equal to weather, and then fall 2, fall 3, and we'll do fall 4. Okay, so I'm just grabbing the first, second, third, fourth of an objects, and I'm going to put it into a data frame. Okay. So they look a little different, right? They're kind of more organized. If we go structure DF, it is a data frame. There are 4 columns, each with that name, fall, and they have the values, weather, apple, things like that. Okay. What about what's a matrix? Is also 2-dimensional. It is a form of an array. So we'll talk about arrays in a second here. Arrays can have multiple dimensions. So a matrix is a 2-dimensional array. Special case, okay. We can make a matrix using the matrix function. All right, how do we do this? So we'll call our data, we'll say fall, and fall has 5 objects. So we need to, it's going to ask, here what it's asking for is the dimensions. So we want to know the number of rows and the number of columns for our matrix. So we've got 5 observations, so we've got to make that match. So we'll say 2 rows and 3 columns. That should work. Think on sub multiple. Ah. Really? Yeah. This is always a pain in the butt for me. Should be. That's why. Okay, my bad. All right, we got to add a 6th thing. So fall 2. Please. All right, I'm gonna pause for a second. What did I do here? You guys pick up on what I did here? You absolutely got it. Good job. Okay, so now this should work because 6 is a multiple of 3. Seriously? Oh, because I didn't use it. Winner, winner, chicken dinner. Okay. Okay. Artec. All right, there we go. So we call matrix, we can identify or index out, sorry, extract values from a matrix, but we need to use essentially their row and column addresses. So unlike data frames where we can use a $sign to like call out by the column, here we have to use the index values of our rows and columns. All right, so I want to extract the value of birthday. What syntax do I need to use? This is just like getting a value out of a data frame when we're using indexing. Remember things like grab the first value, or that kind of thing. All right, so when we're using indexing, what is our notation? Brackets. So we need to tell R what object we want it to look at, and we're going to use our brackets. So what's the address per se of birthday? 22, yes. Dun, 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 dun. Okay. All right, that should be now very easy. Two, three, there you go. All right. I don't really use matrices that much. They are used a lot if you're trying to do like linear algebra on some data. I'll make a note there. Matrices are used most often when you need to do linear algebra. Okay, actually, so let's practice this. Let's, instead of assigning like character strings, let's give a matrix with some numeric values and we can try to do some math with it. All right. We're going to make an object called die, and it's going to have 6 sides. So I just created a new matrix called M1 and I assign the values of our die to it. And I'm going to repeat that for a second matrix object using the same values. I just want to get 2 of these with some numbers in them. Okay, you guys got those 2 matrices now? All right. So remember it was going to go element wise, right? So it went 1 times 1, 2 times 2, and then it yielded the results here in our output. Arrays. Wait, let me stop. Is everyone okay with matrices? All right, all right. Oh yeah, yeah, go ahead.
So when you're making, like when you're gonna call, at least you had to add a 6 value.
Yeah.
Like, so we have to add it. So sorry.
Okay, can you try it again?
I'm assuming you have to add like an even number of values when you're doing the matrix.
You don't. So I had set the number of rows to be 3, whatever. It was a 2 by 3. So it was 6, had to have 6 values in it. Because it's 2 by 3, right? So I could have done a 2 by 1 and then it had to have 3 values in it. An arrays are, they're n-dimensional, so they can have all the dimensions they want. It could be a cube. It could be 4 dimensions. 5, etc. Whatever you want. To create an array, we provide a vector as the first argument. And the dimensions, a vector with the dimensions as the second. So I'm using die here, which has 6 values. So the dimensions, like I mentioned before, when you were asking about whether they had to be even, it also still needs to be 6 because the object, the data that I'm putting into it has 6 values. Now, let's see here. Oh, no, that's not what I want. Come back.
I have 5 values, then what should be the dimension?
It was 5 values. How about try 1 to 4? No, that won't work. 1, 1, 5, because it's 1 times 5. Let me know if that works. Okay. Now I just created a matrix. Remember, this is kind of reinforcing. A matrix is just a 2-dimensional array. Okay. So we're going to add a 3rd dimension here. Okay. What happened? All right, we still have our 6 values, but I created a 3-dimensional object. So it has one column and 2 rows, and this is, I like to think of when we start to get like into 3 or 4 dimensions. 3 dimension is easier. If you think about each one of these as being like a page in a book, right? Each page is a 2-dimensional object, right? And then the array itself has multiple pages to it. So we're still working with the fact that like it's row, column, and now think about this as like the sheet, right? The sheet of the page number, right? So we still, our rows are still in our first position here. Our columns are in our second, and now it's just showing us the first sheet. And if we go down to the second page, the second sheet, right? We have our next set of values. And then I'm gonna scroll down here and we'll go through. And then we have our third. Okay. So how do we call these out? We're gonna call out the value 5 here. Sheet is not an official R term. It's like my way of thinking about it. Okay, so I said we want to extract the value 5 from the array AR3D. Okay, so we're doing this, we're still using the bracket notation. We're just having a 3rd value that we have to call. All right, so it's AR3D brackets. Let me bring this up so that we know where we're at. Here we go. Okay, all right, so walk me through this. Where's this guy at? Where's number 5 at? What's its address per se? 1, comma, We're not that third one, not in the third one yet. Remember, we got to fill in the column first now. 1 and 3. Yep. Okay, we're gonna do one more and then I'm gonna close class. All right, extract the value of 2. I heard 2, 1, 1. Okay, so in all these instances, the third number in our index is the page number. So as you go up in dimensions, the index values, the number of index values will increase. So if we had, let's say, try conceptually, if we had a 4-dimensional object, then think about the 4-dimensional object like an encyclopedia. Yeah, volumes of an encyclopedia. You guys don't even remember those, right? Did you have them in your grandma's house? Yeah, you know what I'm talking about. They like took up a whole bookshelf. Yeah, I did a lot of book projects. You know, like you got to sign Sudan in 3rd grade. Yeah, figure out. Yeah, okay. So the 4th dimension would be like what volume? Hang on here. Oh, we're at time. All right, I'm gonna leave this as a teaser for next class. Okay. Okay. I'm gonna create an exercise for if else for you guys. So you should be seeing that on Moodle. I'll send a message out and we'll go forth and conquer. I'll try to get your exams back as quickly as I can.